Understanding class diagrams. And in this video, we will expand our understanding of classes by modeling the classes in a class diagram. Class diagrams show much more information than the simple list of classes that we've introduced in the last video. As we will see, there are many business rules and many constraints that are captured to this powerful modeling technique. We think of a class as a classification of objects. You can also think of a class as a set of objects. All the objects in the set are the same, or at least they have the same attributes. However, their actual values in attributes will of course be different for each object. The term we use, or we often use to describe an object, is an instance when we want to denote only one object in a class. In programming jargon, to instantiate is to create an instance or to create a single object out of the class. Domain class is a class from a problem domain or the area being analyzed. The modeling symbol for a domain class is a rectangle with two compartments. The top compartment, as you can see on the graph down here, holds the class name, and the bottom compartment holds the class list of attributes. The name of the class is always capitalized, as you can see in customer here. Attributes generally are not capitalized. Both names do include camelback notation or camel case notation. This means when words are concatenated together or combined together, the word in the middle of the name are capitalized, as we see here in cust name or cust number, as well as bill address. Some of the most important information that can be modeled with class diagram is the relationships between classes. For example, we might have a class for a customer and a class for an order. We know that a customer make orders. In UML, relationships are called associations. Please note that we often use the term relationships and associations interchangeably. Each come from a different source. Relationships is a term used in entity relationship modeling, and associations is a term used in UML. Looking at this diagram, we can tell that we have some relationships going on. Mr. Smith is an object out of the customer class who is related or to the accounting department. So he works in a department called accounting, and he also places orders. We're going to talk about the directions between objects in the upcoming slide. And orders also contains some items. Think about this as a receipt. And whether this receipt itself has many items listed below, and the receipt was an order that was placed by a customer who in turn works for a department. Here's an example or a simple class diagram that was captured part of the information denoted in the previous slide. Associations are denoted by connecting lines between classes. In UML, we can name associations, but we can also show the lines with no names as an unnamed association. So looking at this graph, starting with the customer, now going from left to right and reading the association name, we say that customer places orders. Now, if you want to go from right to left, you can say orders are placed by customers. So really the name of the association slightly changed depending on the direction that you go from one object to another. An order consists of items and an item or order items contained within an order. We notice that the connection or connecting lines also has some small numbers associated with it. These numbers are also called multiplicity constraints in UML. And entity relationship modeling is also called cardinality. Let's talk about this graph to explain what multiplicity constraints are. A customer may or may not place an order. That's what a 0 is for. And he could also place many. That's what 0 to many is. If we have an order that was placed, it must be placed by one and only one customer. Now, reading the relationship between order and items, if we have an order, it must consist of at least one item, and it must contain many, or it could contain many. And the order item itself must be contained in one and only one receipt or order. Multiplicity constraints consist of two numbers separated by two periods, such as 0, dot, dot, 1. The first number is called a minimum constraint. It denotes the minimum number of connections between objects, or the minimum number of participation between objects. 0 indicates that there may be none or no participation. It indicates that this is an optional association, so it may or may not have any participation in this relationship. A 1, on the other hand, indicates that there must be at least one association or one participation in this relationship. The second number in this case, again, indicates a maximum constraint. It indicates the maximum number of connections between objects. It is using the number 1 or asterisk. An asterisk denotes to many. So here, 0 to 1, meaning, so you might have an employee with a spouse. An employee may or may not be married. So 0, 1 could be one example there. But if he's married, he can only be married to one person. Okay? That's one, also another example of how to establish a one relationship. Okay, there is also 0 to many relationship, and you can always use 0. 0 always defaults to 0 to many, or you can use the asterisk in this case, or there is also 1 to many as well. So it has to be at least one, and it could be many. Here, it may or may not have any participants in the relationship, or it could also have many. Here, it may or may not have participants in this relationship, but if it does have participants or associations, it's maxed to only one participants. This is only one and only one relationship there. Okay. Let's talk about this example. Oops, did I skip one? There we go. So here's an example with a bank that has many branches. Always, when you read relationships, always read it from the entity that has the one side. A customer must have at least one account, and it could have many. And if there's an account being created, it must be associated with one and only one customer. A branch may or may not have accounts, and it could have many. Why is that? So it could be like a new branch that was just established, but maybe has no accounts yet. But it could also have many accounts. The relationship between account and transaction. An account must have at least one transaction, and it could have many. That's one dot dot or one period many. And if there is a transaction, for example, you're doing a deposit or a withdrawal or a money transfer, this transaction must be associated with one account. We don't have a relationship between a customer and transaction because a customer really can't really perform any transactions unless he has an account. That's why he has to go through the account before he or she can perform any transactions. What about relationship between a branch and a transaction? Well, again, a branch, we can't really perform transactions unless it has to be associated with account in this case. So opening an account is always associated with at least one transaction. Thanks for watching.